Yeah, so what we are going to do now is a very important one, and this concerns structural equation modeling. It's a real and interesting area in research, and which though not yet very popular, but is much more effective than most others, just as effective as a panel regression. Now, VSP does this very efficiently. Now, to get to the structural equation modeling, you first of all have to go to the research data analysis menu, click open, then select structural equation modeling, SEM. Now, just like others, you also have to, it takes time for it to come up. Yeah, good. So, now with structural equation modeling, there are three types of data that will be used. One is the dependent variable or response variable. The second is a group of variables that are called latent variables. And these latent variables are known to influence both the predictor variables as well as the response variables. And then this, the last one, the third one, is the observed or the predictor variables. Just once we're able to define this, then of course our structural equation modeling will be able to kick off. Now, VSP has so much reduced the stress of trying to define it, in a way that only those who have mastered the language of some of these packages can actually program it. But here we have made it so easy because within the execution itself, we have defined the possible relationship that could exist between the latent and the structural, the latent and the observed, as well as the dependent variable. Yeah, so, and at least the latent variables in this case cannot exceed 5, while the observed variable cannot exceed 7. But we know that the dependent variable, which is the response variable, is only 1. So now let us go. We are going to use the same figure that we have been using, that is the same file that we have been using to create, to show an example of this. We are going to use sumters. So now we go to the response variable. In this case, supposing we decide to use a period as one of the response, the response variable. Now let's type period. And then we now move on to latent variables. Now supposing we want to use group, then ing1, ing2, ing3. Which is 4 latent variable now. And then Then we now use meal egg sal SES oil. These are 5 now as our observed variable. Now that we have used meal as a dependent variable in another analysis does not mean we cannot use it as an independent variable in another analysis. So now let us now look at how it's going to happen. Then the next one is to now type the name of the dataset file, which is sumtas, and then now click process. Yeah, that has been done. Now let's see how the whole thing went. Yeah, this is the structural equation modeling. Okay. Now this is where it begins, and the data used for analysis, which is 40 anyway, and then it starts with the same thing again. It starts with defining what the latent variables are. It's trying to tell the reader a dependent variable, which is div here, equals to period. Then latent variables, lat1 equals to group, lat2 equals to ing1, lat3 equals to lat3 equals to ing2, lat4 equals to ing3. Then it's also telling the reader that pre1, that is predictor 1 equals to meal, predictor 2 equals to egg, predictor 3 equals to sal, predictor 4 equals to SES, predictor 5 equals to oil. They give a warning there that warning root official information in matrix is not what? Not P. Oh shit. Okay, so that's and that having done that, we'll now look at. Now it's also trying to tell us that the structural equation modeling parts plot has been saved to value start sem plots dash or PNG. So we are going to look at it later. So there's a plot. Now this is the CEM intervariable values that it produced. LVAR, OP, and so on and so forth. To this, yeah, we have, these are the results, the Z value and P value for each of them, and it's not always that people knows much about structural equation modeling, but I think the reader and the person who is viewing this should be able to Google structural equation modeling and then the interpretation, so that you'll be able to get the full interpretation very well. And then that is just the first one. Then the second aspect is this. This is data line, then the details of the SEM estimates are given as follows. The chi-square, which is this, is 3.42. The degree of freedom is 3. Then the degree of freedom for the baseline is 15. And then the chi-square p-value is 0.33. It's not significant. Then chi-square DOF, degree of freedom ratio, is 27 point this. And then you have root mean square error, that's RMSEA. Then standard root mean square residual. You have comparative fit index, CFI, sorry. Then Tucker-Leeds index, that's TLI. Then incremental fit index, that's that. And then you have goodness of fit index, GFI. I have archaic information criterion, AIC. All other, most of other analysis also bear this AIC and BIC. Then Bayesian information criterion, and then log likelihood. These are very, very important data or outcome in estimation, that is in analysis. So these are that, and that is for the structural equation modeling. It's a very, very interesting analysis. Very, very interesting. Now let us now look at where it is stored and how we can actually see the graph that it produced. Good. Now that is the same plot, that is structural equation modeling plot 202 whatever. But then let us look at the results first. Yeah, that's the results. What we have just seen on the screen is also what is there in the what do you call it now? The text file. Now we can close this one and look at the plot and see the wonder that the structural equation modeling has done. Yeah, you can see this is structural equation modeling plot. Now you can see the colored dots, 4 dots, are the latent variables, and then you can see the d fever, which is dependent variable, and the other 5 boxes, which are the predictor variables. You can see how the predictor variable related to the latent variables. And you can see how the latent variables also related to each other, and how they also related to the dependent variable. You can see that none of the predictor variables actually had a direct relationship with the dependent variable. Rather, they have direct relationship with the latent variables, which in turn had relationship with the independent variables. So that is the wonder of structural equation modeling. I believe this is this particular analysis has made your day, and I believe you are going to know more about it, so that you can apply it, because I believe that this one explains more the reasons why there are certain anomalous relationship between variables which other analysis cannot reveal. So thank you for watching this.